we left off, this is actually question number, let me pick my pen here, 3 on the test that I gave last year. And here's your balanced equation. The question asks, what mass of water will be produced when this amount, well, this amount is 15 moles of CO2, so 15.0 moles, reacts with LiOH. And they don't give us an amount of lithium hydroxide, so that means this guy is our excess reactant. And they want to know how much water are we going to make from this. So starting with, they want to know what mass of water, so we've got to go all the way to grams. So starting with our 15 moles of CO2 and just a simple stoichiometry, since we're in moles of CO2, we get to start with our mole ratio. Same balanced. You put 2 right there. Doesn't matter for our calculations, but you know. 1-to-1 ratio. And then everybody knows the molar mass of water. If you don't, you should. Plug that into your nifty little calculator, and you get, incorrect sig figs, 270. With a little decimal place. Grams of water. All right, next up, we've got some chlorine gas production going on, and we got a couple things we need to know. Let's switch colors here just to keep things interesting. What is the mass of MnO2 needed to produce 12.5 grams of chlorine? So we have 12.5 grams of chlorine, and we want to know how much of that stuff we gonna make. Second question says, what mass of MnCl2, so I'll switch colors here. What mass of that is produced when 0.046 grams of chlorine is generated? So I'm going to start with A, and this is a mass to mass, actually mass to mass, stoichiometry, so 3 steps, 12.5 grams Cl2, mole ratio, or molar mass first, then the mole ratio, and last but not least is the molar mass of our reactant. And that is 86.94. Plug that into your calculator, and incorrect sig figs, we're allowed 3. You get 15.3. For B, again, it's a mass to mass conversion, so it's going to look really similar to this. Beginning of this looks identical to what we started with. And it's this step right here where we do the mole ratio, where instead of converting from moles of chlorine to moles of manganese oxide, we're going to do our mole of chlorine to mole of manganese chloride. And then molar mass. Molar mass of this is 125.8. And if you're having a brain fart and going, hey, where'd she get that number from? Remember, it came off the periodic table. I just took the mass of manganese, added to it the mass of 2 chlorines, and there you go. And this one works out to be incorrect sig figs, point. See, we're only allowed 2 sig figs on this second answer, so 0.082 grams MnCl2. Whoopsie daisy. All right, last question. Super duper easy. They want to know how many moles of H2SO4 will react with 9 moles of aluminum. So a mole to mole conversion, 9 moles of aluminum Since we're in moles and we're going to moles, all we have to use is the mole ratio. So for every 2 moles of aluminum, we're going to need 3 moles of H2SO4. Plug that in and you get correct sig figs. It works out to 13.5, so we have to round it to 14. Alright, if you have any questions or need any help with anything, I will be here tomorrow morning. Otherwise, happy studying.